y dx equals 2xy plus 2 squared. So we're going to solve the differential equation. So we're solving these, or it'll say find the solution to the initial value problem. When you're given a differential equation, in other words, a derivative, and it says solve, we're looking for an equation, not a value. Let's split the differentials and split the x's and y's. We'll have 1 over y plus 2 squared dy is equal to 2x dx. Now, anytime we see variables in the denominator, it's like a knee-jerk reaction to have natural log in there somewhere, to try to jam natural log in. But we don't need natural log. When we integrate this to go back to the original equation, we don't need natural log on this one because we can change this to y plus 2 to the negative 2. This is going to be x squared. When we add 1 to negative 2, we don't get 0, and that's the problem with the variable being in the denominator with a power of 1. You bring it up to the top, it's negative 1, you add 1, all of a sudden it's 0, and that's a bad deal. But this one does not become 0. When we add 1, we get y plus 2 to the negative 1. If we took the derivative of this, we'd have a negative out in front. We don't want a negative out in front when we take the derivative. So we have that negative out front to balance that out. Now, as soon as you take the antiderivative, plug in the value. Don't take the antiderivative, mess with the equation, then plug the values in. That's usually a disaster, but not always. Y is negative 3. Negative 3 plus 2 to the negative 1 when x is 0. So we just have c. C is equal to, wouldn't that be negative 1 over negative 1? Because it'd be negative 1 over negative 3 plus 2. So that's 1. C is 1. Now we can go back up to this line right here, plug in 1, negative. Y plus 2 to the negative 1 equals x squared plus 1. This is negative 1 over y plus 2. We can multiply by y plus 2, divide by x squared plus 1, and we'll get y plus 2 is equal to negative 1 over x squared plus 1. And then just minus 2. Y is equal to negative 1 over x squared plus 1 minus 2. Now I suppose we could get common denominator there, but I don't think that's a big deal. Questions on that? Next one, what do we have? Oh, by the way, on number 7 in the book, it should say x equals 0 and y equals 0. So there's a correction on number 7, and then the number 7 solution is that. So not only is the book messed up, but the answer was messed up apparently. So now it should be all fixed. On this one, dy over dx is equal to e to the x over e to the y. When you divide exponentials, you subtract the powers. Now we're going backwards from that. We have the powers subtracted. We're going to go back to being division. Let's multiply by e to the y and multiply by dx. Whoops, dy there. dx. There we go. We need to integrate both sides. That's solving a differential equation, going back to the original function. E to the y is equal to e to the x plus c. I've just taken the antiderivative, so now I want to plug the values in right away. We have e squared is equal to e to the 0 is 1 plus c. C is equal to e squared minus 1. Let's put that back into c. So e to the y is equal to e to the x plus e squared minus 1. And then if we take the natural log of both sides, we just get y. So natural log of e to the x plus e squared minus 1. Now there's no distributive property of natural logs. There's no distributive property of square roots. There's no distributive property of exponents. So there's nothing we can do with that. It's just done. Don't try to do anything extra. Now what the property says is the natural log of x minus the natural log of y is the natural log of x over y. That's not a distributive property. This and this are very different. Up there, we have individual logs. Down there, we just have one log, nothing you can do. Find the solution of the differential equation, dy dt equals ky, k a constant that satisfies the given conditions. This says the rate, derivative is still a rate, the rate at which something changes is proportional to how much is there. Which means if you have a city of 1,000, they're not going to populate as much as a city with 10,000. The rate is going to be much different for the city of 10,000 because there's more people there. So the more people you have, the faster the rate of growth. Or bacteria, or rabbits, or whatever, right? Anything that can populate. Well, if I see this, if I see find the solution to this, I automatically know this is n equals n naught e to the kt. It's your PERT formula. That's where your PERT formula comes in. You get more, what's it called? When you put money in the bank, you get interest. The more you have in the bank, the more interest you're going to get. Well, it's easy to solve this. You don't have to do this. I know that that goes to that. When I see that, I write that. But where does that come from? It's very simple. We have 1 over y dy equals k dt. We split the differentials, we integrate, we get the natural log of the absolute value of y equals kt plus c. Then we get y is equal to e to the kt plus c. Y is equal to e to the c times e to the kt. Now here's the leap of faith. Here's where you just have to trust me that it all works out. E to the c is just c. 2 times c is c. Natural log of c is c. A constant's a constant. It doesn't matter what you're doing to it. You can do anything you want to it. You can just make it c, believe it or not. It all works out in the end. In the homework, I'll jump ahead a little bit, you'll have this. I think they have 1/2 y squared equals 1/2 x squared plus c. And I had a student come up and say, hey, I'm getting 3 halves and they're getting 3. What's going on here? Well, they just multiplied everybody by 2. And you're like, whoa, wait a minute. They didn't multiply. Where'd the 2c go? C is c. Doesn't matter. It all worked out in the end. It all works out in the end, believe it or not. It's kind of a strange little deal. Kind of a leap of faith you got to take. Trust me, it all works out in the end. All right, back to this right here. This is your PERT formula. This and this mean the same thing. It's just the c is really your initial value. It's your initial value. Well, they've given us the initial value right there. Y of 0 times 0 is your initial value. They've given us the n naught. Now, how have they given us? If I were doing the homework, I would just write this. If they give me y of 0. But how do we know that? How can we just say that? Well, if we plug 60 in for n, and we plug 0 in for t, we get n naught e to the 0. Well, e to the 0 is 1. Well, it turns out n naught is 60. And that'll happen every time when they give you y of 0 or x of 0 or t, whatever, of 0, times 0, right? But now they have to give us another point to find k. We don't have k in this. 30 is equal to 60 e to the k times 10. Time is 10, the value is 30, so now we divide by 60, that's a half, e to the 10k. We have natural log of 1/2 equals 10k, take the natural log of both sides, and then divide by 10. Natural log of 1/2 divided by 10. Now what they'll probably do is write this as 1 over 10, 1/10. 0.1 negative natural log of 2. That's probably what they'd have the k as. So now where do we get that? First of all, 1 over 10 is the 0.1. So you have 0.1 natural log of 2 to the negative 1. That's 1/2, 2 to the negative 1. Now the power rule for log says you can bring that negative 1 down in front. So I'm guessing if we look in the back of the book, they're going to have something like this, possibly. So your final answer is n equals 60 e to the negative 0.1 natural log of 2 t. There's your K. Any questions? Now, on the test, in the multiple choice, free response, whatever, if it says, find the solution of this differential equation right here, you can just jump right to that. Or you can develop it if you want. You can split the differentials and you'll come up with the exact same thing. It's exponential growth or decay. Find the equation of the tangent line to the solution of the differential equation with the initial condition. Equation of the tangent line. If I see equation of a line, I need a point and I need a slope. And we did that over and over and over again. Every time we found a new derivative, we're finding equation of tangent lines. Well, they give us the point, 2 squared root of 2. This is the derivative, that is the slope. So we're evaluating this for 2 squared root of 2. That's equal to negative x over 2 times y, which is negative 1 over square root of 2, which is actually square root of 2 over 2, but AP doesn't really make us rationalize. It's not necessary. We have y minus square root of 2 is equal to negative 1 over square root of 2 times x minus 2. Lots of 2's. Use the tangent line to approximate f of 2.1. Now here's what they're saying. There's some curve that has a derivative that is this right here. Now let's say the original curve looks like that. I don't know what it looks like. Let's say it's that. They picked f of 2. They've centered the tangent line right there at f of 2. Let's say this is the tangent line. Boom, like that. I missed it. Not quite tangent, but I got close. What they're saying is, we got really close to 2. Now use that line to approximate this value. We're going to approximate this value by using that value. And it's going to be a little off. But we stayed close to 2. So it shouldn't be horrible approximation. Now if this said f of 7.1, we got problems. Now we're really far away from 2. So as long as you're really close to 2, that line should be a good approximation. And I have used a calculator here because we're using square roots and it's a decimal value and all that. But great that you can get the answer, but can you explain to me what you're doing? That's what I would like to see. You see, I've already done this. All right, so negative 1 divided by square root of 2. And we're going to multiply that times 2.1 minus 2, which is 0.1. And then I have to add square root of 2. Add square root of 2. 1.344. 1.344. And if it was concave down, maybe the answer was 1.3. Maybe that's what we needed to get, 1.3, but we got 1.344. That's what's happening. Solve the differential equation with the initial condition x equals 0 and y equals 2. To solve a differential equation, we split the differentials and we have y's with y's and x's with x's. We're going back to the original equation. Integrate. Y squared is equal to negative 1/2 x squared plus c. Now they've given us values to find c. 4 is equal to c. So we have x is 0. Now y squared is equal to negative 1/2 x squared plus 4. And we just need to get y by itself. So y is equal to plus or minus square root of negative 1/2 x squared plus 4. But that is not what AP wants as an answer. That is actually, you may not get a point for that if they assign a point to the plus or minus. If we add the 1/2 x over, 1/2 x squared plus y squared equals 4, this is an ellipse. It's an ellipse. And the way you graph circles and ellipses is probably not the way we should graph them. Because the positive is the top half of the ellipse, or the circle, if this was a circle. The plus is the top half, and the negative is the bottom half. Now that's a positive 2 right there, which means they only want the top half of the ellipse. The answer is y equals positive square root of negative 1/2 x squared plus 4. Now if that said y, x is 0 and y is negative 2, then they want the bottom half of the ellipse. So at the very minimum, at the very least, they want the top half of the ellipse graphed. We have no information indicating that they want the bottom half to be included in this. There's no information for that at all. No evidence whatsoever. That point suggests the top half, not the bottom half. So you can do everything right. If you have a plus or minus, you may get an 8 out of 9. We don't want that. We want a 9 out of 9. Or if you're doing this, maybe you should have gotten a 5 out of 9, but now you only get a 4 out of 9. 1 point's a big deal. So hopefully I've emphasized it enough that that is the answer. They don't want plus or minus. Now, your whole life you've been told, when you take the square root of both sides, you got to have that plus or minus. It's true. Until now. Now it's just the plus. And hopefully I made a big enough deal about that. Any questions? That's what we got.
Mr. Smith?
Leah?
If x was negative and y was still positive, would it still be positive?
Yes.
Okay.